Hello, everyone, and welcome to the broadcast. There have been some technical difficulties in trying to fix a freeze issue. It looks like the vertical stream is busted, so that not happening today, or until I fix it. But it's going to be a coding day. We'll see how things go. Let's check in with the kitties real quick, though. We do have, and hello, let's see. Is that Thesta? I think I've seen that name before. But we have Sammy and Sky in the tree, Ember across from the keyboard, Molly to the side of the keyboard, and it looks like Mason on the bed. Yeah, I said your name. Molly says, "You talking about me?" But yes, coding day. Let me actually get my apps open so I can switch over for you folks. But the plan today is to mess with how we're doing physics to see if we can't optimize a little further. Yeah, we do a lot of heavy optimization on this. I really need it to be high performance. We're never going to get to the point of something like Vampire Survivors just because of how complex the behavior of the projectiles are going to be. But I want to get as much as we can out of it. So let's see. Let me just get all of this stuff that I should have already had together, and then we'll go from there. I was kind of scrambling trying to fix that vertical thing. That annoys me, but you know, we'll get there. And now we will switch over. Okie dokie. So one of our shifts was away from trying to use the servers directly over to physics nodes. And that served us plenty well, and it removed one of the complexities that we were dealing with, and that was trying to manage shapes on a single surface, on a single area. And that presents two problems in retrospect. One, the shapes in an area are managed in a unsorted array that is resized every time an element is removed. So there are no blank spots in the array. If you pull one, all of them slide in. Could be a list, but ultimately what it amounts to is it is very hard to align a shape on the area with an entity in the listing. If we were doing like a bullet hell or something like that, where all we care about is the type of projectile that has struck the player or something like that, then we could have an area for every one of those projectiles, and each individual one doesn't matter. But given the complexity of the projectiles, it does matter. Like which particular one got hit, because maybe that one has already bounced or similar. So we can't do that. But it also had the problem that because we were trying to interact with that shape state, we ended up very frequently querying the physics server and asking it questions, and that slows it way down. Because physics, rendering, that kind of thing, they run in their own threads. And if the main thread, the one running the script, asks it a question, then it has to stop, sync up, and answer the question, which removes some of the performance improvement. Lastly, though, we also have an opportunity to start properly object caching. We'll start it with physics. There are some other places we can also use it. The primary thing that I'm looking at is a yarn ball has the same collision area as another yarn ball. A yarn ball uses the same sprite as another yarn ball. So anytime I ask for a yarn ball collision or a yarn ball sprite, I just need one of those things. I don't need a new one specifically for that individual instance. Which would mean that if I create one and then I'm done with it, I don't need to release all of that information. I can just kind of hang it on the rack by making it invisible and no longer sending logic to that visual element. But it's still there. It's still waiting for use. What that should mean is that I'm going to save on all of, I could save on all of the creation garbage collection elements of it, which would save during creation of objects, assuming I'm not creating, hundreds at once. A few at a time, you won't notice them adding or going away. But once there's lots of them appearing and disappearing constantly, we start to get conflicts. So where do we start? We start with a new collision service. So right now we have node-based collision manager, which is a specific type of collision manager. And then we have entity colliders here, which I'm probably going to need to rename to like node collider area or something like that. Let's go find those over here. I want to make sure we can properly utilize this without running into a naming convention conflict. Naming convention conflict being avoided is because we don't want to have to worry about that. So the assumption of this is that there will be layers of them, where the first one creates an area RID, and the subclasses of it say, I'm going to add this shape to that area. Once that has happened, we don't talk to it anymore aside from receiving events. The only time we will set any changes to it are when we're disabling collision on that area. So we should be able to avoid a lot of the issues again. We are going to rename all of these. This is going to be fun. Yes. Which will change all of its children to have node area. So I'm going to do collider node. Yes. This will break some of the data files. So we'll test it before we will fix those before we move on here. Cast, yes. Why did this one get changed? Because these are collider nodes. This is specifically different. So let's get our data files here. And it's not JSON, that's a code logic. Colliders. Node. Circle, and then lighter node capsule. Come on now. And no, collider node spawner. That. You have to start, and then we'll test things. This is probably daisy chaining out. Hey there, Lunar. No naval battle minigame yet. Alright. Logs. Oh, that's an old log file, so it's not a actual loading error. There we go. Collision space manager, collision space manager. Okay, so we need to go down to our this. We're going to rename you. We're gonna change that back here. Here in the collider node collision manager, we are going to open anyway, and we're going to bind a script to you like so. Then we go up into our default startup resources and we check. Okay. Okay, we still have problems. Associated class, script, collider node collision manager. For consistency. If this scene doesn't load properly, then it's definitely going to break down. Okay, it reset itself because of that. Script needs to have the same name as the class that's in it. That out. There we go. So you can see the physics body behavior on everything, and the cost it's putting on us here. I haven't ripped the bodies back out of it yet, but we could, but we're not going to just yet. Item, and this will be partial. It's just in the project as a whole. Okay, so this needs to extend collision manager. Then we need to look here. We don't have to do this, but I actually should be doing this pattern so that the thing that the node is actually shows up in the node tree when I'm looking at it. Because like right now, if I look at our node here, okay, no, we're doing it right. We're doing it right. To Collider node collision manager. Doesn't set itself to that though. Oh, that's because that's what that node is actually called within the tree. Weird that it doesn't change when that happens, though. Derailing a little bit, but... because this extends a node 2D and calls itself Collision Manager. Vote, game. Yeah, this should have called itself Collision Manager when it... oh. I know what's going on. Do that one more time. Close this to our 2D view so that we don't... I don't want to have that script open here, because it can lead to that kind of conflict that we were just looking at. Nope, still close. is a collider node collision manager? The scene is using this script, which when it loads up, this node should rename itself according to the base object. Look at collision manager here. Why would that not change? I'm looking at this because that not changing calls into question how some of this is working. So if we look at collision manager and I do this, it has to go through here because otherwise collision wouldn't be working. And then we go through here. Now if we step over, it should be into here. And if I say this, we look at name, it is collision manager. Now, it could be that the remote tree doesn't properly reflect that, which would be very annoying because the whole reason I'm doing that is so that I can have that override that I'm looking at there. That when I'm looking at the tree, I can see which one I'm using. But apparently not. One of the fun elements that I'll be able to do is that we won't have any other nodes in this, but I'm guessing it just doesn't reflect the name at runtime. Hey, Laura. Okay, we'll move on from that. We'll get these in there. Okie dokie. Close that again. So it's to stop opening it, ideally, but, you know, here we are. Lighter nodes, and these will be going to call this, because these are just going to be raw objects. They're not node based. Don't necessarily want to use too generic a term like collider, since there is a concept like that in Godot. All right, we will call them something very broad here. This is a server collider. Ugh. Physics service is... Every one of those words is not good. Physics service. No, it is physics server. Is physics server. Okay. Well, if we actually end up having a client-server structure, we're going to have to come up with something else for it. Add new item. This is a server collider. And a collider node should probably be... Yep, it's catalogable. Logable. That. And we're going to need a lot of the bits from in here. I will really need to look back at this because I don't know that I'm still doing the thing that this was ultimately for, or that I need to be doing the thing that that's for. That is so in the catalog I could say, give me an entity, but it is very improbable that I will be doing that. This, which is the core thing. Server collider. I'm going to keep that in place so that as we're going through, we will get the copies properly. For the most part, this does nothing, though. Yet. For the most part, most of these are going to be areas, but there's nothing that stops me from having multiple different things in here. I think fundamentally, most of these will be, but we're going to layer them. So we have a raw server collider. We are going to add server collider area, which extends. Does it extend server collider area, or does it? Is it going to be part of one? So I can see the idea of having a body-based one outright. But at this point, I don't know that I want... I don't know if I want to go down the road of having them actually be Godot bodies, because we can see the issues with that already. We're going to do area to begin with, and we'll go from there, though. Okay. Do need an empty one. Which is our JSON constructor. And the same thing for our server collider area. I'm having to type around Molly at the moment, and she is starting to get active enough that she's grabbing at things right now, so she will sit in my lap to toast and get some attention for a bit, and then she starts getting bored and starts grabbing at things and chewing on things. I'm within reach of a metal desk leg that is separate of my main desk, and when Molly is involved, I periodically need to go lean over and ground myself on it. The JSON creates it. We will get this constructor. This is from the catalog. No matter what, there is going to be a point at which we need to initialize it. As soon as we create one of these, we still don't need it yet, is the thing. We don't need it yet. And each collision manager is going to work separately on how it flows through. So we can do whatever we want in here. Set entity. So in theory, we have a JSON ignore. Hey, when the entity moves. Entity is removed. We'll talk through this in just a moment. I like this pattern that was added, and that's that we have an opportunity to add this message. If we don't ultimately need this message, I can just pull it out and move it elsewhere. But what the resolve physics message is supposed to be is for anything that needs to happen at the top of the loop as far as physics is concerned. So the last physics step is actually calculated. Is there anything new we need to do? Like at the top of the new one. So if there were bodies included, we would do things like look at the last proposed movement and apply it here. We can actually do all of the entity move things around, like actually move them during this step. But entity manager, where's our base entity manager? Actually, it's our gain flow. Okay. So we're starting our step here. All entities get told start. Then they get told do anything that you need to do to wrangle physics changes now. So during time passed on an entity, message. So we get a message in. If we're active, we're saying if time passes, then we are going to reset our movement and we're going to say, okay, we did something with this. We get resolve physics. We do all of our movement proposal here. And this is like base handling. So we have, do anything that we need to do, pass it to all behaviors. We have actually added a couple of loops to our cost here. So this is going to be something that we may have to revisit just for efficiency. Not even performance, just efficiency in general. But the basic idea is during time passed, all of the behaviors are going to be proposing movement. So we zero it out, we say it was acted on. We get to the end of the phase and we're going to set our position in animation according to the proposed movement that happened during time passed. Resolve physics was incorporated entirely for the bodies existing. And we can see in our game here, if we remove resolve physics, and we run, we should get much better processing here. No, what did I miss? Yes, it does. So where's our actual problem? Doesn't make any sense. There's just the one. Current document, entire solution, go. What? Nothing changed about this. We didn't get an error on our last run, which implies that something in these guys here is colliding with it. Don't understand what is colliding with that suddenly. Colliders are all catalogable. These are all have a prior commit. In a second. What now? Oh. I mean, if I could tell where the other definition was, is the problem. Like, what is it conflicting with? How is it only up? Okay, we are going to do this. Get those in here because we may need to purge the changes that I'm about to make. Okay, what changed? Why did catalog file reader suddenly change to have extra params? The real question is, why did this change? Why did we suddenly add an extra layer of params around this as an action? How? All right, let's restart some stuff and make sure we don't have some weird lingering symbol because of one or the other, you know? These anyway. It's verbose, but let's get those. Why? Doesn't make any sense at all where services came from. Like, this is where it is. That is the object. Like, I can rename it, but not knowing where the issue has come from makes that problematic. There's nothing that says this can't suddenly happen again. So how can I actually pin down? Because trying to resolve this is just saying, hey, I'm going to rename it. But I don't want it to be renamed. Like, that's the only instance of of a services type being declared. And if I change this to something else, then it gets wordy, and that's annoying for how I'm using them. Hey, schmuggums, I have encountered something inexplicable, and I am trying to figure out how it is suddenly broken. Like, services isn't a good name for this anyway. But it's that suddenly this name already exists in the project. And I don't understand how. Like, why is this suddenly a thing? Because the things that were added do also need to make sure that none of these have verbose namespaces in there, because I'm not using that. Yeah. That's why. Okay. This is what happened. The namespace, it had .services in it because of this folder. Because by default, the C# project wants to have a fully, like, spelled out namespace based on the folders that you're putting them in, which can be used to avoid naming conflicts. Because then you can say, oh, I'm referring to the collision message that is part of, screens.game.messages kind of thing. Which is great and all, but I don't know that I really want to have that structure just now. In the same vein, like, I could have all of these colliders have the same name, but that means if you try to use both of them at once, you have to fully specify them. And I'd rather just the name be fully descriptive. So we'll see how we do on that. But okay, that one is resolved. space. I think there's got to be a setting for that somewhere in the managing of it. But I can't be bothered to look for it right now. But in any event, hello, Schmuggums, hello. It's a beverage here. Drink. So, okay, so we need the concept in a... Let's close everything else. So a physics server collider has the idea of setting an entity. We are going to add all of the relevant entity functions. We care about the animation changing. We care about collidable change. Okay. Let's add... No. If we already have an entity, we're removing the events before we add them. No. If there is an entity, we add the events. In the same way, if there is an entity, we remove its events here. No. No events. Both of these check for null. So if we set the entity, we try to remove them. We set the entity. If we're going to, we clear the events. We set the entity. We add the events in case something is being set in the middle of it. Let's see. So when we're doing a physics server collider creation, whenever we set the entity, we need to be able to attach to its events, but nothing about it until we have, once we have initialized, then we are ready to go. So the actual entity doesn't matter as far as our initialization is concerned. Hey, Colin. Welcome. It is moving along. Our plan for today is to go in and find and create a physics server-based collision handler. We're going to strip away all of the node usage. Finish the cats. Well, I have the one cat bot. We haven't added anything else as far as visual in a while. It's been kind of structural all the way down. Do that as part of a function definition here. So these are critical functions. These have to happen with certainty at the beginning of our process here. You have to initialize it and you have to release it. Setting the entity is one element to it. Oh, instead of setting, we can attach detach entity. When we attach an entity, we are going to set that entity to the object. No, wait. That's not how you do that, though. Okay, this is now protected. And we say we set entity. Then okay. So what we're doing in this is we're saying, I don't even know if these are going to be, no, these are public. And this is virtual. So what we want to be able to do here is that during the process, if we set the entity, it starts listening to the events. Well, life cycle, we will initialize it. Throughout the course of the process, various entities might be attached to the same shape. as long as that same collider shape is shared between them. So every yarn ball has the same collider shape. We will attach a yarn ball entity to a yarn ball shape back and forth. Attach it until it's done using it, detach it when we're done with it. But we will keep a pool, they will still all exist inside of our physics server implementation in our collision manager, but we'll just be like shuffling them around inside of it. Anything else we would need to do? So during the initialize, that's when we're going to allocate everything. That's when we're going to release everything. Collidable changed. We're looking at entity.collidable. So this is doing anything we need to tell it that don't check for collisions anymore. So if it ceases to be collidable, we are going to go into the area and turn off its monitoring values. So whenever we set the entity, we should follow this pattern here. So this is, again, not virtual. But adding events and removing events can be, because there can be extra events that we might attach here and remove that are specific to the entity. So then we have a protected virtual. By default, this doesn't have anything to do. Most of the objects that we're dealing with here keep an entity to themselves, but the entity's objects, things that it emits, it's possible that they don't know which entity that they're necessarily listening to. Like they might subscribe to that event on all entities, so the particular one is not certain, so it passes the entity in. Most of these objects, it is presumptive that the one that you're getting is the one that you've saved, because you're the one that is controlling all of your events. So in general, we should be good. But okay, entity collidable changed calls this. Entity removed is the entity has gone away. So we are going to do set entity. This is the entity has been formally removed. But does this object actually care? Yes, it does. It does. And we're going to have a similar thing up here. Yeah, remove entity collider and entity collider collided. Click delegate, void. Is it ever going to call its own remove? Yes, because its entity went away. This is physics server collider. Entity removed. And public delegate void. Okay, so if its entity goes away, then we know to release everything. Is there ever a circumstance where we're actually going to call detach entity? I think we're just going to call set entity. Because you can just call set entity null and it's the same effect. Yep. Yep, when the entity is removed, we set entity equal to null, which will remove events, and then add events will do nothing. Just have another if there. There's some redundant safety checks being done here. But it's plausible that entity is null going into this. And since add and remove events are virtual, there is no guarantee that they're properly going to handle that null. So we'll just handle it ourselves. Entity is collidable. Yes, then entity collidable. Else false. So if the entity, if entity does not equal null, if the entity exists, then we're going to set collidable based on its collidable value. Otherwise, we're going to say collidable is false, because collidable is independent of the entity. That is related to the actual physics objects that are involved. Okay, quick break and then we will resume. Be right back. Okay, we're back. Okay. Mason. Buddy. Come on. Come on. Hey there. Hey there. Hey there. Mason demands attention. Mason's getting his back scratched. His tail goes like straight up. Enough that it like tips forward a bit, so he blocks the camera somewhat now and again when he's doing that. Gonna really scratch along his spine. We're shedding, buddy. We're shedding a whole bunch, buddy. Let's deal with some of that. There you go. There you go. That undercoat brush going. It's, you know, it's winter month here, so there's a lot of undercoat to deal with. It's generally good to do because that's where a lot of like the dander and skin flakes accumulate on them, is in their undercoat. So when you're brushing them out, you'll notice that there'll be a lot of like, there can be a lot of like flakes. All right. We get this event we call update position. This is something that the children can put overrides in place for. Move we call set entity. Set entity is a fixed thing. But the add and remove events are virtual ones to mess with. Initialize and release are things where we're setting up the objects and safely freeing them. So the workflow should be that when we get a new entity, we are going to check and see if we already have a corresponding object. If we do, we just grab it and add the entity to it. Which should be part of set entity. If the entity is not collidable, we are going to change you to update collidable. By default, we do nothing. As an update collidable, we are going to okay, so in this case it's so whatever the entity is, we are going to update collidable accordingly. I was just petting you a whole bunch, sir. Don't cry at me. Hey, come here. Come on, then. It says, but you brushed me. I wasn't really a fan of the brushing. Look, you have to decide. Do you want attention or no? We're not having this strafing during the stream, sir. Where he'll leave, he'll come back and cry at me and say, scratch my back. And then if I scratch his back for a bit and then stop, he leaves and then comes back and cries some more. What? What? Huh? Come here. Oh, yep. But I can't get belly rubs when you pick me up. Okay, I think we've got all the pieces that we need. So then if we go to area, so in our initialize, we call base. Just in case, we always call base. If okay, what is that? Let's look at some documentation right here. It's valid. Well, that should be simple then. There is a call that we need to make, though. If you try to touch an RID that isn't good, then I believe Godot pitches a fit. Oh, thank you for the follow, Moonstone. Welcome. And again, folks, normally I do have a vertical format stream on YouTube as well, but the OBS stuff broke, so it's widescreen only right now. Just throwing it out there for anybody that might be wondering why. Let's see here. Well, we should just be able to do a... If it's not null and it is valid, if it is null, oh, if it's null, we need to add it. Yeah. We'll need that for release. Server 2D dot area create. So that gets us this. Then area set space, which is the area, which is our area RID, which is the space RID, which is Checking. Just sparing you guys documentation here. Servers using physics server. No. Checking. Rigid body. Okay. Get world 2D space. Okay. Yeah. Get world 2D dot space. Get world. Oh. We have lost some functionality here. Might be okay. Some methods are missing. Is this old documentation? No, it's the stable version. Looks like it's a node function, I bet. But no, I'm not seeing an extension. This implies it's a node, though. Okay. So that should be node 2D get world space. Okay, so that means we need a concept here in our collider. ID space ID. So I think initialize then needs to have an RID space. The assertion being is if you mess this up, the whole thing's going to go haywire, and I am kind of fine with that. Okay, so we have created the area and we have asserted that it is in the world of whatever space we have given it, which is the world of the physics node. And the physics collision handler is just a kind of global free floating node 2D. So it should have the same kind of general space layout. Sherbet seems to have, between Sherbet and Sky, they cleared out the food, so Molly is kind of looking looking at the scraps of the dish. I'm not too concerned. Molly always gets plenty to eat. She isn't a gorger fully, but she's technically a grazer, but she kind of passes by the food dish more than the others, you know? She's snacky. If it's 0. No. It's not a nullable type. Okay. This is just generally concerning to me. Ah, okay. Okay. Very specific type of it, so. This is an actual type and not an object. It's a struct, so it's a very primitive object. Data structure. Okay, so we have the area it is created. And we are going to, in this collider, okay, when we update position that is relevant to the objects that are created. So whenever we get an entity, we should set its position to that. Are we updating collidability in position? Ma'am, well, I know, but you can't push buttons. You don't update collidability and update position. Update collidability whenever collidability changes. And whenever we're not touching this one. This is a collider node. That's not what we're touching. Got to that, but okay. Okay, so we're going to update our position every time we set the entity. Date position, call the base on it. So we say physics server 2D set area, set transform, which is going to be our area. And then we need a transform 2D, which has should just be 0 2i and the entity's position. So that gets us an area once we've created it. Then here item, which is a very verbose name. That means it needs these two methods here. And we need a in here. Make sure these are all flagged accordingly. I could... Okay, all of the shape creation logic is going to... I don't want to fork all of this stuff. I could encapsulate them down to a lower level like this, and I'm going to. This is... There's nothing really about these objects that have a difference to them as far as, like, I could have shape here, and they all have a shape. But that doesn't really help. So I have a public float radius, the getter setter. That will make this JSON accessible. So we'll do this for each of the different shapes, and we should be able to get the same general results from all of them by doing this. Also in the area, we need to wire up collision. Okay, so then during our So in the initialize up here, we're going to do the same things. Oh, tech did. If we have a valid area, because we're going to need that. We do shape. We should have an example of that in here. Okay. Shape type, shape create. So this gets us a circle. The area is valid, and because this will happen after, and not shape dot is valid. The assertion here is once we've made the shape, once we've made the area, we do not recreate them. Before we forget. Click override. Release. Now this is going to be a different pattern because we're going to have the children release first, just in case. RID area RID. Then we'll call the base. Then in the same way, override, release. Shape. Okay. So this will cause it to cascade back up. So we release the shape, we release the area on up. Hopefully this isn't a problem. I know that if during the method we have this problem, then there will be an issue. Additionally, we run the risk of freeing these when we're in the middle of handling, but we should not be releasing these until the whole system is winding down. So we'll see if we need to do it this way or the other way around. Or if there's going to be any constraints. Server2d.shape. Do we need get data first? Just set data. Data. This will be shape. And then And I wish it was possible to scroll this. But I believe we can just pass in radius here. Each shape has its own thing. Like if it's a rectangle, you pass in a rectangle 2 object. That kind of thing. Okay, physics server. Add shape. Area, comma. Okay, so this creates that listing. We need... That is just the rectangle. Let's take a look at this in area. Set monitorable. Supposed to be a callback. Monitor callback. So then we have our area RID, and then we need the proper kind of callback. Once again, it would be great if we saw the whole function here. No. That won't help us. Okay. Body moved is... That's not what we want there. So we're going to go to our physics server 2D. We're going to have area set. Monitor callback. There we go. Area monitor callback. Okay. We will need to look at this because it's possible that we're going to get, we're going to need to track whether there is still something attached to it. but we'll see here. Okay, so we have area set callback. We need an integer. It needs an RID, and then it needs 3 more integers. Which is our status. New area RID. Instance ID. Area shape index. So this is where it will get a little tricky, is when a collision happens, we're going to report that we are the one that collided. I may need to expose the entity on it. We are going to need to track the these objects by an RID. Or in some way get an object out of it. If we're going by physics server, then I think I can have a root RID concept on them. As then we're going to get an area shape index and a self shape index. How will I do that? When we are in our example here, we're using that. So if we go in and we have body moved, new callable this method name. Oh boy. Method name dot. Is reliant on it being a node, I bet. So we just can't have that. We can't have a raw name entered here. Oof, okay. object, dot object. How are we going to do this? We could just have a Godot object, which is the callback, but a Godot object... because I want to be able to create these using a catalogable. But the real thing is the Godot object. That is going to be what it interacts with. We could just relay, though. We can just relay the event up through a generic Godot object. Okay. We are still going to need to figure out how we do... Get those events in there. So we just want collided, and we want to be able to call out when we collide. What we collided with. Okay, okay, this is actually viable. Okay, okay. know if we need to worry about this, but okay. This is an internal class. The only thing we care about in it is a relay callback from it. Server. It's called monitor callback. Here, and we're looking for this. And to put you here, to extend Godot object. RID area, RID. Just do area. Then this also has that's right. This doesn't do any of this. It's the other way around, though. This gives me the callback. We have the entity, so we don't need the entity here. The whole point of this thing is to get this callback. It's all we care about. So it is this area, this local area collided with this area. So each of these needs to have an RID that they reference. So a physics server collider has a root RID. Whether it's an area, a body, it doesn't matter. We're going to say this collided with this RID. So all physics server colliders have a root RID, which will be used as a key for them. Like we will find it by that. Okay. So if we get this, then we're going to call our area monitor callback, which will report an RID. Okay. So if not area dot is valid. So if we don't have one, we're now going to mess with it. Server 2D dot area set area monitor callback, which is area common new callable this comma method name dot area monitor callback. Come on now. Click, click, click. Okay, so then area monitor oak with so we will get the area that we collided with when we do this. But we need to go back up into here. Here's our space RID. Here's our JSON nor public RID root RID. Okay, and we are going to go into collider area. I'm going to keep that. We are going to remove this, and we're going to find all the spots that exploded accordingly. Root RID. So, be back for you in a moment. Okay, so when we're wiring collision events, so we have our Godot object here. We have our definition for one. So JSON ignore. We don't serialize anything. The JSON ignore is not technically necessary because that's only relevant when you are serializing it to file, and that's not what we do. Server collided area monitor. Ah, that is a class name. Actually, though. Yeah, okay. Equal to new physics server area handler. Oh, there was a trick to this. That's not going to help. Quickly here. Okay, it's just you knew it. And then when we're done with it, we have to call free on it first. Okay. So we are okay to call new physics server area monitor handler. And instead of set area in the physics server area monitor handler definition, we are actually going to put that as a constructor. So we don't need to handle area. We are just going to use it right there. Just do this. Because I know which collider was there. I only need to get the other one to figure out what its entity is. I don't need to know the RID of the root one. I have already got it. Because it'll be the one that raises the relay event. RID. Then this equals area monitor that. Then we are going to grab our event. Say if collided is present. Okay, we have to have an invoke method here. Not invoke, collided with. Wonder if there's a pattern for actually writing it a better way, but we'll see. Okay, so this relays up and says we collided with this RID. That RID at the manager level is going to be what we catch. We are going to short circuit some of this for now and get a proof of concept running as soon as we can, but let's get this. Do a lot of commits like that. They're not good commits, at least as far as naming and descriptiveness, but I don't really care about the line name as much most of the time. What I changed right now is more important in the ability to revert, you know? Whoops. That commit had an error in it. So since we have this area monitor handler during release, we also need to say our area monitor handler, not free. This is get rid of this object. Okay. Okay, let's look at our other collision manager and get an idea of what flow we used here. We need to subscribe to entity added. We're not going to do this node caching thing the way we have been. We're going to hack some of this in place. Equals entity added. collection, which will be a dictionary of RID to Physics Server Collider. Always be that. Actually, okay, that's enough, buddy. That's enough. We're going to get out ahead of this a little bit. We're going to say this is string. We're going to copy this first. String, then that, and then that. Okay, so the whole point of this is to say, here is a list of RID to Physics Server Collider objects based on their type. Actually, no. We're going to... catalogable, so it will have a name. Log is down here, isn't it? I moved it to here, yeah. Catalogables have a catalog name. Yes. Then we also have a area of string to a list, which is of ID. Okay. So these are all of them by their RID. Doesn't matter what type they are, this is where they exist. This is all of them by type. So when we make a new one, we're going to say, I got this dictionary or this catalog name. If it's freshly created and it's available, if it's available, it will go here. It will be added to this immediately after it is initialized, because we will have a root RID. So whenever we need one, we're going to look and see, is there one of this type available? If there is, take that one and put it into play. If there isn't, we're going to create a new one of the corresponding type. And that is ultimately, copy it from the dictionary, initialize it. Then we're going to load it into this collection, and we're going to hand it off for use. It's only when we have removed the entity from one of these that they go back into the available cache here. there's some more collision logic that we're going to need to add in this, but okay, so we have an entity dot collider key. So this is our server collider. Collider is equal to services catalog. Get catalogable. It's been out of play a little bit too long here. Physics server collider. It has to be this pattern. If it's not, we have an error case because this collider can't run. Ultimately, our model is like our startup resources is not for being able to hot swap these. It is for development purposes, but also being able to set other properties when we load them in. Longer term, at some point, I need to set up an actual service model in it so that during like initialization of some of the major objects, we are giving them the services that they need to operate. But for now, we'll do it this way. If cache contains key, collider key, and greater than 0. So this is, it is available. There is a cache available. Else, we are just going to make one. Say colliders. Initialize. And it is going to be here that because this is a collision manager, it is a node. I'm going to have get world 2D dot get RID. So we initialize it with the space value here, and we are going to say colliders add. Oh no, it needs to be after we initialize it. It has to exist first. Dot add RID, so collider dot root RID comma collider. Collider dot set entity. declare this up here. We're using it one way or the other. So collider is equal to collider cache into collider key pop. Shouldn't be peak, that's a Q. Am I? Should be pop. Because we want to get the next value. So we have a push here, right? We don't have push either. It's a dictionary of strings into a queue of RIDs. DQ. Come on now. These are physics server colliders, not RIDs. Set entity. Both of these cases we do this, so we don't need to repeat that. During cleanup, say collider cache clear, just in case. Shouldn't be necessary, but for colliders for each value pair of RID to physics server collider, colliders, air.value dot release. Let's look at a collider when we release it. It has a root RID, and during its release, we need to say no, it doesn't know how to deal with its root RID. This is ultimately an abstract class. We're never just making a raw physics server collider. unpeck typing here. There we go. I know. Then in the collision manager, when we are attaching them here, this is also when we're going to add some events. No. You don't get to mess with that, baby. No, quit it. Being all squirmy. Ember is wriggling around. Get some intensive back scratches. Equals collider entity removed. There we go. Now on collider entity removed, we no longer care that it is colliding. So we're going to take these and we're going to remove them. Then we are going to collider cache, add. It's not. Add a method here. Contains key collider dot entity. Need to get its entity, so we need physics server collider. Its entity needs to be public. Set. Catalog name. Oh, no. We're going to keep that I can see its entity, though. That will be relevant. Not, then collider cache, add that, comma, new, that. Cache, catalog name, add, push, NQ. I don't. Okay, so NQ DQ makes sense. Like the words are valid, 100%, but I get tripped up on it because it is a type of collection, or it is an ordered collection. with a fixed entry and exit point. And when I was learning those structures, the terminology that was used in the text and in the classes, and in all of the materials I was learning from in general, was push and pop. You push into it, and it goes into the entry point, and you pop it off of wherever it comes out. Is that universal? No, but the stack object uses that. Okay, so we put it back on the queue. We remove its events. Its entity is already cleared because entity was removed. But it still exists, is the thing. It will have gone non-collidable during this process. Why it didn't change all of those instances, but maybe I just missed something. Maybe I didn't properly do a replace name operation like I thought I did. Oh well. Position, update collidable. It's how we update collidable. Set an entity and it's null. Update collidable. So when we clear the entity, we want detach the events. We're going to update the entity to whatever it is now. We're going to call update collidable. However that area uses it, whatever it does to update collidability, it's going to perform that. So protected, override, update collidable. So we'll call base here. So physics server 2d.area set it's monitoring and monitorable. RID, comma, false. Wait. This is entity.collidable. I think there would be a set for monitoring, but I think that might be a kind of a shortcut that the Godot node is using. That, and that, and that, that. But for here, we are actually going to say If it's collidable, then we'll use the collision mask. Otherwise, we'll use 0. So the mask is what it looks for. If we say it is not collidable, you can't find it. And if you if its mask is 0, it can't find anything else. We are going to set these initially. Once we set the entity, it is now ready to go. So when we set entity, oof. Do I want to do this? If we are setting the entity, that's where its collision will actually be determined. But it's detached from the entity is the trick. Okay. If there is not a null entity, we'll do that. Else, it is not monitorable, and it has no mask once it is set this way. If there is an entity, when we update collidability, which should only happen when the collidability changes or when we initially set the entity, then we are going to set its monitorability based on the entity, its mask based on the collision mask, and set collision layer to entity dot collision layer. Entity category. That's right. So whenever we set an entity, its collision layer gets set. That's when it matters. It ceases to matter when we set this to false when the entity is removed. Okay. All right. Collider collides. We do need to know which one. So this collided with this RID. Physics server collider, comma. Okay. I think we're going to call it here for the day. We've still got targets to roll with, but first let me check first. Let me check a couple things here. I think we can wrap up for the day. I do want to run a little longer next time, but frankly, we've got ground to cover, and the vertical stream glitch is frustrating. So I'm thinking of scheduling the next one for Tuesday. We'll have to see, though. We'll have to see. In the meantime, folks, let me find my buttons here. Buttons. I hope you had a good time watching with us today. Progress-wise, we've got the start of our physics server-based collision pattern, as well as some caching for it. This should be useful. We'll see how it ultimately plays out. We will be picking it up for further next time. But again, I hope you had a good time. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment. All of those buttons are generally good. So if you press them, it helps the channel grow. If you'd like to consider financially supporting the channel, you can do so through platform-specific means like memberships, subscriptions, bits, and all of that, as well as off-platform methods that can be found in the link tree in my video descriptions and bio. With all that said, I hope the rest of your day is good, and I'll see you next time.